What if I told you there's a way to write complex logic in Rust that's cleaner than if-else chains, more powerful than switch statements in other languages, and totally type-safe by default? In Rust, match is the Swiss Army knife of control flow. You'll use it to destructure enums, handle multiple conditions, branch logic based on types and values. And it's so expressive, you might never want to use an if-else again. So buckle up, we're going to deep dive into match, explore its arms, patterns, wildcards, and even match guards, all with live code examples. Let's go. All right, let's begin with the basics. The match expression allows us to compare a value against a series of patterns and execute code based on which pattern matches. This is a simple example of matching a number. Here we're matching the value number. Each pattern is called an arm, and the underscore is the wildcard that catches anything not matched by the previous arms. Let's run this. Rust will print 3, because number equals 3. What happens if we change number to 42? Let's try it. See, now we get something else, printed, because none of the specific patterns match. The underscore is like a safety net. It's required if you don't cover all possible cases explicitly. Now here's a cool trick. You can match multiple values with the pipe symbol, just like a logical OR. So here, if x is 6, 7, or 8, it'll match that third arm. If x is 4, it matches the range arm. And by the way, yes, this expression 3 equals 5 is a range pattern. It matches any number from 3 to 5 inclusive. This is way more readable than writing a long series of if-else checks, right? Let's now look at something more powerful, destructuring. Match isn't just for integers, it's for enums, tuples, and even structs. Let's take an enum example. This is where Rust shines. Match allows you to handle every possible variant of an enum, and the compiler actually forces you to cover all cases, or include a wildcard underscore arm. Let's say you forget to handle one of the directions. Rust won't even compile. That's safety baked right into the language. Let's do a quick example with a tuple. So what's happening here? We're destructuring the tuple directly in the pattern. If the first value is 0, we match the first arm. If the second is 0, we hit the second. Otherwise, we fall to the third. You don't even need to manually extract values. You do it right in the pattern itself. Powerful stuff. Here's another advanced move, match guards. You already know how a basic match works. You match a value against patterns. But sometimes you want to add extra conditions to your match arms. That's where guards come in. They let you add extra conditions using an if clause right in the match arm. Let's see it in action. In this case, we use exif to check more complex conditions. This adds a lot of flexibility. The match block becomes almost like a clean decision tree with filters. So what's happening here? We have age equals 21. Age could be any number. Instead of matching the exact value of age, we are saying, if it is x and x is less than 13, you're a kid. That's what the if x less than 13 part does. That's the guard. Let's run it. And boom. Since the value of age is 21, it goes to the third arm, and we get, you're an adult. Let's change that value to 18 and run again. Now it says, you're a teenager. This is beautiful because we're keeping logic tied to patterns and avoiding ugly nested ifs. It's readable, clean, and expressive. Now one last tip. Match is an expression in Rust. That means it returns a value. Let's see this in action. Here, the result of the match expression is stored in the message variable. This is super handy when you want to assign based on conditionals without writing messy logic. Now let's talk about iflet. Sometimes you don't want a full-blown match with multiple arms. You just want to check one thing. That's what iflet is perfect for. Here's a classic example. First, we initialize a variable config max with an option type containing the value sum, 3u8. For those who don't know, it represents an optional configuration value that is present and set to 3 as an unsigned 8-bit integer. It then uses an if-let statement to check if config max actually holds a sum value. If it does, which is true in this case, it destructures the option, binding the inner value 3 to a new variable max, and then prints the message. The maximum is configured to be 3 to the console. In short, we're saying, if config max is sum max, then go ahead and do something with it. Much more concise than writing a full match like this. This expression underscore equals is boilerplate we don't need, and Rust lets us skip it with iflet. Let's go one step further. What if we want to combine iflet with a guard? This is super handy when you only care about one match case and want to keep your logic linear. Okay, now, let's talk about while let. This is used when you're looping through values as long as a pattern keeps matching. Let's use an example with a stack. All right, what's going on here? We have a vector, and we're popping elements off it. Each call to pop returns an option. So as long as pop returns some top, we keep printing and popping. Once it's empty, pop returns none, and the loop stops automatically. Let's run this, and as expected, we get this output. Pop 3, then 2, and then 1. No need for manual loop termination or checks, just pattern matching doing its thing. Let's bring everything together with a more complex example. Let's say we're building a system that checks messages and handles them differently based on type and priority. This code defines a message enum capable of representing different types of messages: email with subject and urgency, SMS with content, and a ping with no data. In main first, we create a vector populated with instances of these variants, and then iterates through the vector. Inside the loop, we're matching against an enum, and we're using guards inside destructured patterns like urgent, true. We are using a match statement to pattern match on each message, determining its specific type and extracting relevant data, like the subject from emails or content from SMS, to print a unique, descriptive line to the console for each message based on its variant and internal values, differentiating between urgent and regular emails. Super powerful. We're writing logic that would take tons of boilerplate in other languages, and it just reads like a story in Rust. All right, time for a quick challenge. Write a function that takes a day of the week and tells us whether it's a weekday or weekend. Here is a hint for you. Use enum and pattern matching together. Drop your solution in the comments.